Hello. So today I want to discuss the chain rule. The chain rule basically is useful when you trying to take the derivative, for example, of sine of 2x. So it's not sine x, but it's sine of 2x. Now, what happened then if you take the derivative of sine 2x? What will happen with this 2? Because we know the derivative of sine x is cosine x. So the chain rule is basically a way of taking the derivative of a composition of functions. For example, if you have f composed with g of x, or we say f of g of x. So if we name it as uppercase h of x, then we want to take the derivative of this function. So what happened is we're going to describe f is the outer function and the g is the inner function. So when you're taking the derivative of a composition of two functions, so you're going to use what you call the chain rule. The chain rule says that take first the derivative of the outer function. So you take f prime, and then when you get the answer, you're going to evaluate f prime at the inner function, which is g of x. And then times, then you multiply, you take the derivative of the inner function. So you get g prime of x. So the derivative of f of g of x is f prime evaluated at the g of x times g prime of x. So that's what you call the chain rule. It's a chain, a sequence of derivatives. So an example, you are given y equals sine of 2x. So when you look at this, you have two functions. The outer function, the outside function is a sine function. The inner function is 2x. So chain rule says when you're taking the derivative of sine 2x, first take the derivative of the sine function. So the derivative of sine is cosine. So when you get cosine, then evaluate cosine at the inside function, the inner function. So you're going to have cosine of 2x times. Then you take the derivative of the inside function, which is the derivative of 2x, which gives you 2. So the answer to the question of finding the derivative of sine 2x is a 2 cosine 2x. Another example is you have y equals tangent of sine of x. So you have a function, outside function or outer function, which is the tangent function, and then you have the inner function, which is sine of x. So to find y prime, first take the derivative of the outer function. So the derivative of a tangent function is secant square. So when you get secant square, you're going to evaluate secant square at sine x. So basically you plug in sine x. So you get secant square of sine x times. Then you take the derivative of the inner function. So the inner function here is sine x. So the derivative of sine x is cosine x. So you get the derivative of tangent of sine x is secant square of sine x times cosine x. Another example, you have the outer function is cotangent function, and the inner function is x squared plus 2x plus 1. So when you're asked to find the y prime, first you take the derivative of the outer function. So the derivative of cotangent function is negative cosecant square. Then you're going to evaluate it at the inner function. So you're going to get negative cosecant square of x squared plus 2x plus 1. And at times, then you take the derivative of the inner function. So you get the derivative of x squared plus 2x plus 1 gives you 2x plus 2. So that's the answer. So this is an example where you have three functions. Okay, you have the tangent function, the sine function, and the cosine function. So you want to find y prime. So we're going to use the chain rule as a sequence of derivative. So first, we're going to view this as the outer function, and the sine of cosine x as the inner function. Okay, we had step by step. So chain rule says to take the derivative of tangent, and then we're going to evaluate it at the inner function. So you take the derivative of tangent is secant squared, evaluated at sine of cosine x, times, then we take the derivative of the inner function. But the derivative of inner function, okay, is itself a composition of two functions. So first we take the derivative of sine, and then we're going to evaluate it at the cosine x, and then times the derivative of the inner function, which is cosine x. So derivative of sine is cosine. Evaluated at cosine x, you get cosine of cosine x, times the derivative of cosine is negative sine. So you get the derivative that you're looking for. Okay, this is about the chain rule. So we can start with the chain rule right here. Thank you.